Flash flooding for the plains, Eastern Rockies, and the South, but we only have severe weather for the Eastern Rockies and the South. Good morning, I'm meteorologist Pew. Today is August 29th, 2025. So I know I talked about flash flooding for the last few days, but unfortunately this is going to continue for the next few days. So for today, we have a flash flood risk for South Dakota, Nebraska, and also New Mexico, Colorado, and the Texas Panhandle area, and also in the South from Texas all the way to Alabama. In terms of severe weather, we only have a marginal risk stretching from South Dakota all the way to the Texas Panhandle, but also from Eastern Texas to Louisiana. And we have a couple of risks all over the place. We have a 2% isolated tornado risk from Nebraska and Kansas, and we may see isolated damaging winds in all the marginal risk areas, but we may only see hail from the Eastern Rockies. Okay, so time frame starting with the plains, you guys are already seeing convection this morning and afternoon. It's going to dissipate a little bit, but it's going to start re-intensifying around 1 p.m. Central Time. But unfortunately, we're going to see a lot more convection into the night and into the next morning. And some places may see rainfall totals up to 5 inches. For the Eastern Rockies, you guys are going to see isolated to scattered cells around 1 p.m. Mountain Time, and it's going to travel eastward. Rainfall totals, we're looking around 1 to 2 inches. And for the South, similar to what's happening in the plains, you guys are already seeing convection this morning and afternoon, and it's going to dissipate, but it's going to ramp up during the night around like 12 to 1 a.m. And this will also persist into the next day. And then shout out to the Northeast, you guys are going to see isolated to scattered shells and maybe a thunderstorm or two around 1 to 2 p.m. Eastern Time, and it's going to travel northeastward. Okay, so why this is all happening, if we look at 500 millibars or midway through the troposphere, we still have those two features, the ridge and the trough. So starting with the ridge in the southwest, we actually have some pretty decent wind shear, which is going to tilt those updrafts and prolong the storms. But this is actually from remnants of Tropical Storm Juliet that was in the Pacific, that was in California, and reached over here by today. And in addition to remnants of Tropical Storm Juliet, it's bringing in a lot of mid-level moisture as well. Now looking at the surface, we have a lot of low pressures that we need to look at. And remember, low pressures are counterclockwise flow. So in combination with both the low pressure in the plains and the one in Colorado, it's bringing in southerly winds, and especially into the plains. And these southerly winds are bringing more of that tropical moisture into the plains, which is adding more fuel. So as of right now, it's going to be producing a warm front into this area, but eventually there's going to be a cold front that we pass through that's going to provide surface lifts and produce those storms later in the night. Now what's happening in the Eastern Rockies, the low is starting initially from the western part of Colorado going to the eastern part. And what's initially going to cause these storms to form is probably a dry line, where we're going to have warm dry air going down slope from the mountains into the warm moist air. And because drier air is denser than warmer air, it's going to provide that surface lift. But as this low pressure deepens and travels eastward, it's going to provide more easterly winds, which then the winds are going to travel upward with the terrain and provide more orographic lift. And then for the south, we're going to have a stationary front, which is going to provide a lot of constant surface lifts, but also with the low pressure there, it's going to recycle that tropical moisture. And for the northeast, we just have your classic low pressure attached with a cold front, and that's going to travel northeastward, providing those surface lifts. And that's why we have